Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the scheduling of a multi-core processing, what are the types or how they can be implemented in an operating system, what are the levels of scheduling, and what are the advantages and disadvantages of the multi-core processing scheduling. Often, symmetric multiple processor scheduling provides several separate physical processors to access the processes and learn it very smoothly and reliably. Now, a recent trend in multiprocessing scheduling algorithm is a multiple cores placed in a single chip. These multiple cores can have their own architectural state, thus appears to be operating system as a different physical processors. Now each physical processors can have their own private ready queue of processes or common ready queue where the processes that are ready to execute stores. Now the multiple processor scheduling becomes complex with the several issues. The first issue is that when multiple cores want to access data from memory, it spends a long time waiting for the data to be available from the memory. Say it is called a memory stalling. In this memory stalling, there can be various reasons which can be affected that. The reasons can be like a cache miss or a cache hit plus cache miss. Now in this way, the cores can lose up to 50% of time for waiting of the data to be available from the memory. Some operating systems remedy this situation by adding 2 or more hardware threads per core inside every core of a single chip. Now this single chip processing system is faster and can consume less power than each processor placed in different processor chips. Now in this way, with a dual core, dual hardware thread mechanism, the operating system hardware threads are provided as the logical processor which are available to run the actual software thread. So now there are 4 logical threads to run as a software thread for this operating system. For example, the Intel Itanium is a dual-core, dual-hardware thread which appears to be a 4 software thread to the operating system, whereas AltaSpark T3 CPU has 8 hardware threads per core and 16 cores in the processor. Thus, it keeps 128 logical processors appears to the operating system that are available to run. Now, there are 2 ways by which this multi-core processing scheduling can be done. The first one is the coarse grained. In the coarse grained scheduling algorithm, the thread executes until a long latency event appears to be executed on that thread. Now, because of the delay of this long latency event, like a memory stall, the thread switches to another thread between the exact processor. Now, the specific processor can choose from 2 or more threads that are available on the logical processor section of that processor. Now, switching among the threads have become increasingly costly because the instruction pipeline might be flushed before switching it to another process, as it contains the instructions that are needed to be changed while it was moving to another switch and another process thread. Now, when the thread begins execution, it fills up the pipeline with its own instructions. Now, in this way, coarse-grained multi-threaded programming is a costlier but a little bit easier too, as it switches threads among a processor. Now, in a fine-grained scheduling algorithm, in contrast, which uses this fine granularity or frequency, like the boundary of an instruction cycle, it can switches the threads. It also implements some logic while switching the thread. That is why it reduces cost of the switching. Now, a multi-threaded multi-core processing scheduling has 2 different levels of scheduling. In one level, all the scheduling decisions that must be made by the operating system, that which hardware level thread is to run on the software thread of that processor. Now in this level, the operating system can choose any of the available scheduling algorithm. In other level, it is to decided that which core will choose which hardware thread to available to run on the processors. Now the processors can run on any of the hardware thread that is chosen by the processor. Now this way it can be implemented also in several ways. Like for the UltraSpark T4 CPU can choose a simple FCFS algorithm which should choose from the 8 hardware cores that which cores should be scheduled to run the process. But the Itanium Intel processor chooses among 5 different activities or events that are triggering for the thread switching. Now it levels the scheduling of the urgency termed as 0 to 7. A low urgency process should be put in the 0 and the highest urgency process should be put in the 7. Now depending on the urgency that the event it has triggered, this process is put it into the 0 to 7 ranges. In this way, it can schedule the cores among the processor. Now various operating systems like Java and Linux uses this second level and the first level as well. Now the scheduling algorithms are implemented in Multicore are complex because the ideas and all parameters must be set by the programmers to actually achieve the result. That is all for the multi-core processing scheduling. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.